kind of came with whatever I chose, apparently. All right, so add or subtract fractions. So today we want to add and subtract, and then we want to deal with complex fractions. So in order to add and subtract fractions, what do I have to have? Common denominators. What's the common denominator between 3 and 6? So I multiply top and bottom by 2. Now we can combine the numerator, and the denominator will just be 6. As you involve more than one process, or more than one rule, or more than one skill, a lot of people get confused. They might even add these 6's and get 12. No, you leave the denominator alone. The top, I have 6x minus 10 plus 8x minus 1. Now what? Good. Combine like terms. That's the correct phrase. Very good. Gracie. 14x minus 11 over 6. Can you reduce anything now? What if you had a 12 instead of an 11? Then you could factor a 2 out of the top and a 2 out of the bottom and cancel. Okay? Good. B, do you have common denominators? You can have variables in the denominator. That's fine. So you just have x plus 4 on the bottom, 2x minus 3 on top. Does anything cancel? Nope. So you're done. Okay. How about C? What's the common denominator? X times x minus 1, right? Let's do that. So my new denominator will be x times x minus 1. If you want to distribute that through, go ahead, x squared minus x. But I'm going to leave it like that in case something cancels later on. In the numerator, what do I have? Good. 2x squared plus 3x minus 3. Does 2x squared plus 3x minus 3 factor? It doesn't. We should check. If it did factor and it had an x minus 1 as a factor, then we'd be good to go. But it doesn't, so we need to leave it. And finally, the last one. I'm going to rewrite this as 5 over x plus 2 times x minus 2 minus 6 over x plus 2. Now, why did I do that? Very good, Emily. You can see that you have one in common, the x plus the 2. So I'm going to have the x minus the 2 up top and the bottom in order to create a common denominator. Tell me, before I did that, what might somebody be tempted to do that they shouldn't do for D? Yeah, multiply the top by x squared minus 4 over x squared minus 4, and the top and bottom here by x plus 2 over x plus 2. Now, if you do that, you'll still end up with the same answer, but you'll have to do an extra reducing step. So you can still get the same answer, but you have to do an extra reducing step. Okay. 5 over x plus 2. Okay, so our common denominator is now x plus 2 times x minus 2. What do I have in the numerator? Good. You see that this is a negative 6, which brings me to a minus 6x and a plus 12. I can combine the 5 and the 12. Negative 6x plus 17 over x plus 2, x minus 2. And a lot of people wondering about the x plus 2, x minus 2 on the bottom. They want to change it to x squared minus 4. That's fine. They're equivalent. Show me whatever you want. I leave it like this so that if something came up as a common factor, I could cross them off. Any questions? Going once. Going twice. Thrice. Okay, so I'm going to give you a new packet. Not a new packet. a new sheet to follow along with. Problems. And so I did pick one of the hardest ones. So I'll do 3 problems and kind of spread out some of the topics here. So the first problem is number 3, which says 1 over 3 plus h. I'm sorry. What does it say? Minus a third? All over h. This is complex fractions. So last time we didn't do too well with complex fractions. I should say a couple years ago when I started. Last year went a lot better. I think that this year will go very well as kind of how we have it organized. A complex fraction is when you have a fraction over a fraction. And if you see, this is h over 1. So you have 2 fractions in the numerator. You have 1 in the denominator. They need to be combined together, okay? You got a thought? Yeah, we will eventually multiply by the reciprocal. But before you do that, you have to create a single fraction over a single fraction. Anytime you see a complex fraction, deal with the top separately from the bottom. Do you need to do anything with the bottom at all? No, it's done. The top, now that's a whole different story. Our common denominator is going to be 3 times 3 plus h. So we're going to use that skill that we just learned about adding and subtracting fractions in order to help us with this. Top and bottom here by 3. And that will give us a new resulting fraction. Okay, so what do I have in the top? I've got a 3, and this is like a negative 1, right? So I'll have a minus 3 and a minus h over, what's in the denominator? Sure, I'm going to leave it as 3 plus 3h just in case something would cancel. If you'd like to write it as 9 plus 3h, that's fine. Over h over 1. So now they are 2 distinct fractions. Okay, I have a single fraction at the top, single fraction at the bottom. But before I multiply by the reciprocal, what should I do at the top? Simplify. 3 minus 3. Going to go away. I'm left with negative h over 3 times 3 plus h over h over 1. Is there any more simplifying that I can do before I multiply? Okay, so everybody does understand now that this is the point where we multiply by the reciprocal. You cross it off times 1 over h. Now is a point where we can look to see if things cancel. What cancels? The h. What are you left with on top? A negative 1. And on bottom, 3 times 3 plus h. If you want to write the negative in front of the 1, or in front of the fraction, or in front of the 3, it doesn't matter. All have the same value. The negative can go on top, on bottom, or in front. Any place. But you can only have one negative. Any questions how I ended up with that as a result? Question? Because what this is right here is this is like 2 over 5, okay, divided by 1/2. That's what this problem's like. You don't like to do that, do you? You want to multiply by the reciprocal and get 4/5. That's the same thing we're doing. Does that make sense? Always easier when you just plug in numbers and see what the property is. Okay, let's try another one. This one's the harder one. Okay, number 8. Okay, I think it's a minus 3, and is it a plus x? Minus x. Okay. So, do you have one fraction in the numerator? We got 2, don't we? And you've got 2 in the denominator. So we need to work with both the top and the bottom in this scenario. What's going to be the common denominator in the top? Good. So you're going to take this side and multiply the top and bottom by x plus 2. And that will give you a common denominator. How about the bottom? What's the common denominator? X. So I'm going to multiply the top and bottom by x. Good. Numerator, got 1. I'm going to distribute my negative 3 through. Negative 3x minus 6. So 1 minus 3x minus 6 over x plus 2 over 4 minus x squared over x. Any questions how I got that step? Okay, what can I simplify here before moving on? Yeah, the 1 is 6, so I'll write that as negative 3x minus 5 over x plus 2 over. Sometimes this is a good place to, if something does factor, you might be able to save a step here. There's 4 minus x squared factor. It's the difference of 2 squares. It's not x plus 2 and x minus 2. It's x, I'm sorry. It's 2 plus x and 2 minus x. Let's make sure we get this straight. Is 2 plus x and x plus 2, are those the same? Yes, they are. Addition is commutative. You can switch them back and forth. Is 2 minus x the same as x minus 2? No, those differ by a factor of negative 1. And I'll show you that trick here in a minute. This is all over x. What do I do at this point? Multiply by the reciprocal. So I have times x over x plus 2 times 2 minus x. Thought those x plus 2's might cancel, didn't you? Well, they don't. Does anything cancel? Watch the trick. If you wrote your final answer pretty much like this, I would be okay with it. But here's how it's written from the back of the book, okay? Here's how they write it. They write this x. What do you think they factor out of this? A negative 1. And when you factor a negative 1 out of this, it becomes 3x plus 5. Now let's look at the bottom. You have 2 of the x plus 2's, don't you? So you can write that as x plus 2 squared. And then I don't care. It does not matter to me. But I'm showing you this because this next step I do will be a little bit of a trick. And second of all, sometimes the book will write things differently. And so last year, a lot of people came up with this answer, and they're like, well, this is what I got. Why is it incorrect? Like, it's not correct. I just want you to see how it is the same. I'm going to take this 2 minus x, and I'm going to factor a negative 1 out of it. When I factor a negative 1 out, what does this turn to? A positive x and a minus 2. So now it cancels. Negative 1's. So I would accept this. But everybody came up with this last year, and they looked at the answer. It didn't match with that. And I'm just saying that all that happened was they combined the x plus 2's, and they factored out a negative. So again, part of the challenge of algebra is understanding, are these equivalent? Yes, they are. And that's how they got to be equivalent. So does everybody understand that I don't care if you take out the negative or not? If I do, I'll be very clear about it, and you'll know. Okay. Last example, then you have the rest of the hour to work. We do problem number 12. So flip your sheet over. When you see this, a lot of people immediately want to put the y squared on the bottom and the x squared on the bottom. You can't do that. This is like y to the negative 2 over 1, right? So you could put the y squared on the bottom of this part, not the bottom of the whole thing. It doesn't work like that. So I'm going to rewrite this to look like 1 over y squared minus 1 over x squared. All over 1 over y squared plus 1 over x squared. These look very similar, don't they? Okay, well, we're going to see something that works out here. But right now, nothing cancels. What's going to be the common denominator in the top? Very good. What's going to be the common denominator in the bottom? X squared, y squared. Let's write the new fraction. What's the fraction in the top? X squared minus y squared over x squared, y squared. The fraction in the bottom, x squared plus y squared over x squared, y squared. Do you see what's going to cancel? I now multiply by the reciprocal. X squared, y squareds cancel. Now, before we let that problem alone, does x squared minus y squared factor? Does this piece right here factor? X plus y times x minus y. Does this factor? No. So will you find anything that cancels between these two? No. So this does factor, but it won't cancel with anything. So we can write the final answer as x squared minus y squared over x squared plus y squared. And when you see that, every year when I write that, it's just, you just want to try to cancel something. Sure does look like something should cancel, but nothing does. Nothing does. Okay, that's it. So the deal is that you have